All right. Number 1 says, let's look at this sequence. All right. What kind of a sequence is this? It's geometric. So I'm going to go ahead and just as a refresher, I'm going to write our formulas over here. These are the formulas that we have had so far. And actually, this is all of them. This is all of the formulas. Now, the A sub n formulas give us terms. So if you wanted a number in the list, this is a list, right? If you wanted another number out here in the list, you would use one of these formulas. Remember, the D stands for common difference, so that's arithmetic. The R stands for common ratio, so that's geometric. The S's are the formulas if you wanted to add all these up. You remember talking about that the other day? If you want to add all these up, you're going to use the sum formulas. Okay? Now, let's look at problem number 1. Actually, let's skip for a minute down to C. Find the 10th term. C says find the 10th term. Can you do that? Can you find A sub 10? That would be the 10th term. Well, I hope you can. We're going to use this formula right here, right? Because you told me my sequence was geometric. So the 10th term will be what? 3 times 2 to the 9th. And we'll just type it in our calculator, and that'll be the answer. That's easy. Right? Now, D says, find the sum of 12. All right? There's 3 formulas that find sums. Which one of these are we going to use if we want to find the sum of 12 terms? The last one. This one, I can't remember whether in this period I got to this or not. In some classes I did, some I didn't. This is the formula for an infinite geometric series. And we'll look at that. If we haven't already, we'll look at some problems like that. But this is not infinite. This isn't saying add these up forever and ever. This is saying add up 12 of them. So what would the formula tell us to do? We're using the last one there. So what are we going to write? 3 minus 3 times 2 to the 10th over 1 minus 2, which would be negative 1. Look at the formula. Oh, it should be the 12th. I'm sorry. I was thinking this one. Thank you, Delaney. You're right. It's to the 12th. We're finding the sum of 12 terms, not 10. Finding the sum of 12 terms. Thank you. This one you're going to type in exactly as I wrote it. 3 minus 3 times 2 to the 12th. And then change the sign. So it should be 12285. Is that what you got? Now, what is the rest of that problem talking about? Well, B, we did talk about. B, maybe the vocabulary bothers you, maybe you can't remember. But B, you can handle. B says find the explicit formula. The explicit formula means, and it means for this particular problem, it means the formula that will give me whatever term I want directly. You figured that out. The explicit formula is just for this problem, A sub n equals 3 times 2 to the n minus first. This is an explicit formula. We just make it specific to this problem by putting in 3 and 2, our first term and our common ratio. This is the formula that will give me whatever term I want. So if I wanted the 100th term, could I get the 100th term from this? Yeah. That's what it means to be an explicit formula. It gives you whatever term you want. Just, you want the 18th term, great, here it is. Now, the first one, we didn't talk about this word. What does the word recursive mean? Well, the concept is very, very simple, and I do not want you to get confused by the notation. How are you getting from term to term in this problem? Multiplying by 2. So what you're saying to me is, if I have a term, any term, and I times it by 2, what will I get?
Double.
The next term, right? And the next term after the nth term would be the n plus first term. So in other words, if you took the 6th term and times it by 2, the 6th term times 2, what would that give you? Here's the 1, 2, 3, 4, 5, 6. Here's the 6th term. If you took it times 2, you'd get 192, which is the 7th term, right? How do you get the 8th term? You take the 7th one times 2. That's what it means to be recursive. Recursive means tell me how I take a term and get the next term. So explicit says, if you want the 100th term, just put in 100 and you got it. Recursive says, how do I get from the 99th to the 100th? You take a term, a sub n, do whatever you need to do to it. In this sequence, it's times it by 2, and that will give you the term that comes after the nth term. What's the term that comes after the nth term? The n plus first term. What's the term that comes after the 12th? The 13th. After the 20th term comes the 21st term. So what comes after the nth term? The n plus first term. So this is called your recursive formula. You do need to include the starting point when you write that formula so that you know where to start. We'll do some more examples of recursive as we go, but there's a couple more things we need to look at here. Okay, now number 2, anybody know what that squiggly line means? Sigma, it definitely is a sigma. Anybody know what it means to the mathematician? It means sum of, absolutely. When you see a sigma, you know you're going to sum. Now, you have 3 formulas that sum. How do you know which formula to use? What is a key on? Which formula we're using? Whether it's geometric or arithmetic, right? Well, this is a little tougher to tell. So here's what I want you to do. I want you to start right here with n equals 1, and I want you to put that in there. What do you get when you put in n equals 1? You get negative 1, right? Sigma means sum, so I'm adding. Now I'm going to put in 2. What do I get when I put in 2? 1. Now I'm going to put in 3.
It just add by 2.
And when I put in 4?
5.
5. Now, can you tell, all I did was start right here, this bottom number, smallest number, I start right here, and I put it in, okay? And then I put in the next number, and the next number, and the next number. Can you tell now whether you are arithmetic or geometric? Yes, you are arithmetic. So we're going to use this formula right here. This is our arithmetic sum formula. Okay? So here we go. I'm supposed to add all these up. Now, I started building the sequence by plugging in 1. and then I plugged in 2 and 3 and 4, and then I stopped because you saw what was happening. But technically, I should keep going until I plug in 10. So the last number in this sequence would be 17. Start with this number, and we're going to plug in every single number until we get to here. Okay? What do you think if that was missing? If that were missing? If there were no top number, what do you think that would signal to me? Infinite. That would be when I would use this formula, right? Because that would mean there's no stopping point. It just keeps going, 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 going. Okay. So how many terms am I adding up? How many terms are in this list if I started with 1 and ended with 10? 10. There's 10 of them, aren't there?
You already have 4.
Kids? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the formula says 10 over 2. What does this mean? First term, which is -1. What does this mean? Last term, which is 17. So we've got 5 times 16. It looks like our sum is 80. That was pretty easy, wasn't it? Let's look at the next one. It's another sigma. Let's see what's going on here. How did I start the last one? Let's write out a few terms, see what's going on. So we'll start by putting in 1. What do I get when I put in 1? 2/3. Now I'm going to put in 2. Now when I put in 2, this becomes 1/9 times 2, so it would be 2/9. Now I'm going to put in 3, 2/27. Is that enough for you to see what's going on? We only write out enough so we figure out what's going on. Can you see what's happening? Arithmetic or geometric? Geometric, and we are multiplying by 1/3. So which of our formulas are we going to use? These are our 2 geometric formulas. Which one shall we use?
The bottom.
No,
Oh, infinite.
Gotta use the infinite one because there's no ceiling on this, right? It's just going to keep, we could keep writing out terms for weeks, right? So now we want to add them up. So it says the sum is going to be, according to the formula, the first term, which is 2/3, over 1 minus the common ratio. What did you say I was multiplying by? 1/3? Oh my golly. Look at this. 2/3 over, what's 1 minus 1/3? 2/3. What's this sum work out to be? 1. Amazing. They will not always all equal 1, no, but that's how they work. But they won't always equal 1. Okay, that's pretty neat. All right, next. We have one more sigma. Let's see if we can sort it out. Okay, first term, let's put 1 in. What do we get for our first term?
You get
Negative 6, very good. Let's put in 2. Remember, we square first before we multiply, so the next one will be?
-12.
Negative 12. And the next one, let's put in 3. Watch it, 2 cubed is?
-24.
8. That's going to be negative 24. Now, stop when you figure out what's going on. Logan, I'm going to come back there. And it's not going to be good. Okay? Is this enough for you to see what's going on? Okay? So what have we got? We've got what kind of sequence? Geometric. Stephen, you taking notes?
Yeah, I'm getting on notability.
We got enough here to tell this is geometric. Which of our geometric formulas am I going to use? This one or this one? These are both geometric. The bottom one, because this time I'm not infinite, am I?
No, ma'am.
So I'm adding up how many terms. I'm starting with 1, going to 10. That's how many terms? 10. The formula says take the first term minus the first term times the ratio to the 10th over 1 minus the ratio. Did you notice I pulled a switch right here? Because it was minus a negative. So that sum is negative 6138. If I type that in correctly?
You can label it negative.
What?
You can label this negative. Like in the, after the 1, I think you said like switch the sign or something, so it wasn't.
Well, because no, this is positive. I had to make it negative because I divided by -1. That's why I switched the sign.
It's like the answer's still being stamped.
Well, yeah, this is going to be the answer. Whatever that works out to be will be the answer. These are all negative numbers, Delaney. Of course, when I add them up, I'm going to be negative, right? Now, let's look at number 5, kids, because it's backwards. Number 5 says, okay, you've got the set of numbers. Now, you write them as a sigma. So you make the sigma.
So it's arithmetic sequence.
Okay, so Mr. Stark has noted it's an arithmetic sequence. Let's look at our arithmetic formula for a minute. And what would be an explicit formula for this set of numbers? It's arithmetic. What's my first term? 3. What's my common difference?
2.
2, n minus 1. So 3 plus 2n minus 2, it looks like 1 plus 2n. There's my formula for this set of numbers. Now, I didn't do that magically. There's no mystery. You told me this is arithmetic. That's my arithmetic formula. So I just plugged in my specific first term and my specific common difference, and I came up with this. That is what goes here. Now, what do you want to put here and here?
N 1.
Let's start with 1. Now, you do not have to start with 1, but it is best to start with 1. It's easiest to start with 1, otherwise you have to mess with this and you really don't want to. So we're going to start with 1. Notice, if you put 1 in, what do you get? If you put 2 in, what do you get? See, you got it. You just need to tell me where to stop. If you put 9 in, what do you get? Which is your last term. That's it. That's your sigma. Good job. Not hard at all. How did we get this again? Where did this come from? Our formula. When in doubt, use your formula. Now this next problem, you're probably thinking, Mrs. Ford, what does this have to do with anything? Well, I'm going to tell you what it has to do with stuff. That decimal, which you'll notice repeating, could be written like this. Now just look at that for a second. Remember, when you add decimals, you line up the decimal points. Would that equal this?
Yes.
Now let's take a look
Yeah.
at these numbers. Is there a pattern to those numbers?
Multiply by 100.
Multiplied by 100th. 1/100th? We are multiplying by 1/100th each of these terms. So if we are multiplying by 1/100th, what kind of sequence is this? Geometric. Now, what does this dot, dot, dot mean? It goes on forever. In other words, it's an infinite geometric series. Our formula says we take the first term and divide it by 1 minus the ratio. And what did you say the ratio was? What did I multiply by? 1/100. So we have 0.34 over 0.99, which is 34/99. And if you put into your calculator 34/99, you will get that decimal right there. This is the fractional form of that repeating decimal. Now, those of you who know the math league cheer, part of the math league cheer says, we are number 0.9 bar. Now, what does that mean? Well, 0.9 bar means 0.9999999, right?
We're almost there.
That's a repeating decimal. That is the decimal 0.9 plus 0.09 plus 009 plus blah, 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 blah. That is an infinite geometric series. The first term is 0.9. What is the ratio this time? What am I multiplying by this time? Not 1/100th. 1/10. So 1 minus 1/10. What's 1 minus 1/10? 0.9. 0.9 bar is exactly the same as 1. Repeating nines are the same as 1. So when the mathletes say we are number 0.9 bar, that's the same as saying we are number 1, because 0.9 bar is the same as 1.
That's so funny. We are number one.
Okay. All right. Now what I'd like you to do, we got a little bit of time left and we got to do some stuff. I need you to find in your packet, you have, well, I guess it's right on the back side of that. Right on the back side of the odds and ends sheet. You have some old limit quizzes. The last time we talked about this, which would have been, what, Friday, we did some limit work. I'd like you to look at problem number 1 and tell me what the limit is. In problem number 1, what's the limit? We're on the back of the sheet we just did. Problem number 1, what's the limit? Or another way of asking that question is, if you were going to graph this, where would you put the horizontal asymptote? Not 2/5. Watch it, I got sneaky. 2. Because it's 2n over 1n.
Ooh.
I mixed the numbers around, you got to pay attention. So it's 2n over 1n, so the limit is 2. Look at number 2. Do not be confused by all the gobbledygook in the problem. Bottom line, what's the biggest power you got on the top? Squared. What's the biggest power you got on the bottom?
Squared.
They match. Compare their coefficients, that's your limit. What have you got? 6/7. The limit is 6/7. Kids, I don't care what else is in the problem. It is not important. It's the power, the biggest powers that you look at. Okay. Let me skip down. Let's look at number 5. We're going to come back and get the rest, but let's look at number 5. The limit of a subtraction problem, an addition problem, a multiplication problem, a division problem, it doesn't matter. But when you have a limit situation like this, where the problem is in two pieces, you take the limit of each piece and then do whatever operation is there. So we're going to take the limit of 4, and we're going to take the limit of that fraction, and we're going to subtract them. Okay? Now the fraction you should be able to do right now. What is the limit of the second part of that problem? 3/4. Now, anybody want to take a wild guess what the limit of 4 is? 4. The limit of a constant is the constant. You're exactly right. So the limit of the first part of the problem is 4. Harry, the limit of the second part of the problem is 3/4. So the limit of the whole thing is 4 minus 3/4, or 3 1/4. The answer is 3 1/4. If that had been a plus sign in there, you would do it exactly the same. If it had been a times sign, you do it exactly the same. Okay? All right, let's look at number 7. Tell me about number 7. We talked about this on Friday, number 7.
Top heavy.
It's top heavy. And when it's top heavy, that means the fraction is exploding. Therefore, it is divergent. Remember that word? Divergent. What does divergent mean? Infinite, no limit. When you are top heavy, you diverge. Look at number 8. Bottom heavy.
0.
When you are bottom heavy, you are getting smaller and smaller, so your limit is 0. Okay. Number 9. I just told you how to do this. Do not be confused. What's the limit of the first fraction? 1. What's the limit of the second fraction? 2/3. Therefore, the limit of the whole shebang is 2/3. Number 10. -7/2. Now, is everybody clear on the ones we've done?
So 7's answers.
Yeah, why did we skip that?
What?
It's not the
7, the answer is divergent. There is no limit. There is no
What?
limit to number
What?
7.
How'd you do number 9?
Limit of the first piece times the limit of the second piece.
Oh, okay, so this is 1.
No, I say divergent. Now, we need to go back and look at number 3, number 4, and number 6. Okay? Because what's going on in all of those problems is you don't have like n's over n's and stuff. What you have is a fraction to a power. And as you find the limit, as n approaches infinity, of the fraction to the power, that means the power is getting bigger and bigger and bigger. So for example, the first one, that's a 1/3. So that means you're taking 1/3 to the first, and then 1/3 to the second, 1/3 to the third, 1/3 to the fourth. Tell me what's happening to your answers as you take 1/3 to bigger and bigger and bigger powers. It's getting smaller. The limit is 0. Why is it 0? This fraction is bottom heavy. Right? And if it's bottom heavy and you keep going, what always happens? It gets smaller. So I don't care what the exponent is. I mean, we could put an n plus 5 here. We could put a 2n plus 5. Irrelevant. If that fraction is bottom heavy, you're going to go to 0. Period.
Bottom heavy meaning just the bottom number is bigger than the top number?
Yes. So the value of the fraction is less than 1 is the real way of saying that. Now look at number 4. Is that fraction bottom heavy?
Yeah.
Yes. I don't care that there's a negative in there. It's irrelevant. The fraction is bottom heavy. What's the answer to problem 4?
0.
Now take a look at number 6. That's divergent. Why is that divergent?
Because it's top.
The fraction is top heavy. All right? Now, I want you to look at the other side of that page there. See, there's 10 more problems. This was a makeup quiz. Fill them in. Head down that column. We've got time to fill these in and check our answers, and then I will shut up for the day.
This is for divergent. Is that basically just no solution?
No, you either write no limit or you write divergent.
Okay, I can't do like a zero
Nope.
cross.
I want to see the word divergent or the word no limit. We do need to be somewhat mathematical. Okay, so John Preston, you already passed them, you probably handed it to me.
It's right here on your desk.
What's the first one?
Divergent.
Hey, let's see if we can do these on our own, Katie Klein.
Okay.
Oh, goodness.
Okay, remember, tomorrow is Thursday, the field trip is Friday. So if you had not yet turned in your permission slip, I need it. Get it to me.
I don't know why.
I'm not sure what
Maybe just put.
I'm gonna do it.
All right, how we doing?
Eight.
How do you know? There's
Number one, divergent, no limit. Everybody good on that?
Yes.
Number two, zero. Everybody okay? Number three,
6/5.
6/5. Number four,
7, 4, 7.
7 and 4/7. What is the limit of 8? 8. What is the limit of the second part? 3/7. So your answer is 8 minus 3/7. Number 5, divergent. Number 6,
1/2.
1/2, because the limit of the first part is
Negative.
-1, and the limit of the second part is -1/2. So when we multiply those, because the problem says multiply, we get 1/2. Number 7, 6. I seem to be fond of turning things around, so pay attention to that. Number 8, 0. What is the highest power in the problem, kids? 1. And where is it? It's in the bottom. And when you are bottom heavy, your limit is 0. What's the power? Square root of n. What power is that? When you say square root of n, what is that? That's 1/2. This is bottom heavy. The limit is 0. Number 9,
2/5.
2/5. And number 10, I tried to get tricky, but I'm sure I didn't trick you. The answer is 0, because pi is 3, right? And the denominator's 10. So that's bottom heavy. All right? Now, tonight your homework is in the packet, pages 2 and 3. So you're going to get some practice with some word problems tonight in the packet on 2 and 3. If you don't have these formulas written down, you might want to take our last minute and get them written down, because you're going to be using those
Can't wait till
formulas
next week.
to do your homework.
You get to sleep in.
Oh, yeah. Especially like math is hard for you. It's crazy, yeah, because everyone has ECA testing and we that stupid snowbake thing.
Okay, everyone?
We have to practice what to do when we snowbake, even though we're not going to.
Have a good day, John.